let's talk about pendulums. Pendulums are very straightforward. Usually we have a fixed point and a string of length L. Remember, we have to measure our length in meters. And there's a bob at the end. Now the bob has mass M, but it turns out we don't ever use that. And of course, it sits there and it swings back and forth. All right, goes back and it goes forth. We know a couple things about certain points of a pendulum. We know that when it's at its equilibrium point, the velocity is a maximum, but the acceleration is 0. We also know that when it is extended as high as it's going to go, the velocity is 0, because remember, it stops right there. But the acceleration is a maximum because it's turning around, it's reversing its direction. Now we can find the period of any pendulum, quite straightforward. It's 2 pi square root of L over G. If you've measured L in meters, and G is 9.8 meters per second squared, the period is always measured in seconds. It's how many seconds it takes to go from any one point forward and back to that point. So you can measure period any number of ways. You can measure it for it to go up, back, and up, but I find that one confusing. I find it much easier to start it aside and watch it go forward and back, and we'll do that in class. Now, you're designing a pendulum clock to have a period of 1 second. So T equals 1 second. How long should the pendulum be? We're looking for L. Well, let's see. I know the period is 2 pi square root of L over G, and I'm looking for L. So I'm going to solve this for L. So T divided by 2 pi is the square root pi of L over G. Now I need L by itself, so I need to get rid of this square root, so I'm going to square everything. So L over G is T squared divided by 2 pi. So the length it needs to be is T squared times G divided by, y'all didn't catch that, did you? This is 2 pi squared. That's exactly what you will do. I did that on purpose, right? Haha, no. Okay, remember, teachers always make mistakes. Divided by 4 pi squared. So now let me plug in. The period is 1 second squared. G is 9.8 meters per second squared. Divided by 4 pi squared. Now you can use pi as 3.14. That's fine. If you do this, you get 0.248 meters, which is indeed 24.8 centimeters.